So to wrap up our discussion of the coastal plain, we should take a look at the Floridan aquifer. This aquifer occurs in Florida, as you might imagine, but it also occurs on up the coast into Georgia and South Carolina. And so let's see, right? So there's the overlay, and we can see how it wraps up here into South Carolina. Now, we have got a couple of different colors here. The green color is the aquifer itself exposed, and then it's covered and confined by a unit, the Hawthorne confining unit. So the Floridan aquifer occurs here in the subsurface, but it's not exposed at the ground surface. It's also exposed here, but it's in the subsurface, so you have to drill down through some confining layers to get to it. And that can be important because the confining layers will protect the aquifer from some contaminants, at least in some cases. So there's the big picture, and this Floridan limestone aquifer consists of materials that were formed as a reef. And so the limestone is the remnants of reef bearing or reef dwelling organisms like corals. And when they die, they form their shells form a hard structure with very high porosity and permeability. And this is a limestone quarry in Florida, and you can see a very nice exposure of some of this aquifer material. And so if we zoom in on this face where this guy's looking, we see that the material looks like this. And you can see some layers, and then that tube structure is from one of these reef-dwelling organisms. And the scale on this is probably about a foot or so. And these are the pores in the rock. So they're quite large, many millimeters across in some cases. And so this creates a material that has very high permeability. But another important distinction about this aquifer is that it's made up of the mineral calcium carbonate, and that mineral is soluble in carbonic acid. Carbonic acid is formed when CO2 combines with water, and so there's plenty of CO2 around to form carbonic acid that will dissolve this material. And so one of the consequences of that is that these carbonates get dissolved out, and there are cavities that formed. And here's one. This is a dissolution cavity in this limestone. So the material has been dissolved and stripped away. And in this case, it's say a meter or so across, and this feature would be then in the subsurface and would create a fairly open region that would be even higher conductivity. But of course we can imagine that these cavities could be much larger than the one shown. Here's a cavity shown in a different quarry. This is a very big cavity. Well, this is it's probably 10 meters across right there. And here's some other examples. This is a limestone quarry, but this isn't the Floridan limestone. This is in the Midwest. So the limestone is a little bit different, but the dissolution features are shown very well here, so that's why I'm using this slide. And what you can see is these features right here. This is a fracture, vertical fracture that extended up here to the surface, and then downward flowing water went along this fracture. It was localized and flowed along the fracture and dissolved out the limestone walls. And so you can see that the fracture is flaring out here and kind of flares out, and that surface right there is also part of this outwardly expanding fracture zone. You can see it here. There's another vertical fracture, and it expands out this open cavity, and again here, and again here. So these are vertical fractures that can be followed upward to these cavities that are manifested at the ground surface as sinkholes. So the occurrence of sinkholes in areas underlain by limestone is a consequence of the solubility of the limestone, and it will be an important part of the aquifer system as well. So here's one of the consequences of having sinkholes around. They will collapse, and in some cases with some fairly severe consequences. So if you're driving to work and the sinkhole collapses under you, it could be a rather distressing time. And another consequence of having these cavities is that they are, you can view them as very large pores. And so here's a case where we've got a very large pore in the subsurface, and in fact you have what really amounts to a stream flowing in the subsurface. And so in areas underlain by limestone where you can have this dissolution, you can get underground streams like what I show here. But this is really one of the only settings where you can have an underground stream, literally. The public seems to conceive of underground streams being very widespread, but in fact that's not the case. Around here, in areas underlain by clastic sediments, sands or silts and clays, you have water in the pore spaces, and the pore space is probably smaller than a millimeter. But in areas where you can have dissolution, you can have these large pores and water flowing in very large conduits. And in some cases, the conduits are completely submerged, and they're large enough for people to get into and swim around and explore. So here is the consequence of having these dissolution features. If you just take a look at this limestone setting and imagine that we have recharge and flow through the saturated zone discharging to the stream. So that's the basic scenario that we saw really on day one. And in this case, it's modified by the hydrogeology because the limestone, the solubility causes these conduits to form, and that really localizes the flow. So what I'm showing here is a sinkhole underlain by a vertical fracture that's been dissolved out. And here's another one. Here's some other ones, and then these go down vertically and intersect these flat-lying conduits, like the one that we saw where the person was swimming through the conduit. Okay, so we've got a series of flat-lying conduits that's following bedding, and vertical conduits that are following fractures. And they interconnect and form a system of these interconnected large conduits. And then we superimpose on that the flow system, and we get a flow system that looks like this. The sinkholes tend to act like funnels, and they funnel the recharge down into these vertical fractures and get into the aquifer system. Here's another scenario where the discharge is occurring as a large spring up on the slope, and then there's a large flow that goes down to the stream. An important consequence of this is that these karst aquifers, like the Floridan Aquifer, tend to be quite vulnerable to contamination. If you have contaminants that are introduced in the sinkhole, for example, it can easily get into the aquifer, and then it can move at very high rates because the flow through these conduits can be very rapid, much more rapid than through a sand. So that makes them very vulnerable, and that means that in areas where there is a confining unit that would protect these kinds, the development of this vertical open conduit, then the confining unit can be an important protector of the aquifer against contamination coming down from the surface. And so here is the confining unit. It's hard to see, but it's this gray layer, and that's protecting that's making this aquifer is vulnerable to contaminants, but because of the confining unit here, this aquifer is much less vulnerable because the surface derived contaminants are not circulating below it. Okay, so let's wrap up this one with a look at these same statistics that we saw for the clastic coastal plain aquifers. The transmissivity is even higher than the clastic aquifers. Low end is 1,000, and it goes up to 100,000 square meters per day. And you recall that the clastic aquifers in the coastal plains started at 500 and went to about 10,000. And so here the high end is 10 times higher than the high end in the clastic aquifer. And it's so transmissive because in places where you have the aquifer cut with these large conduits, that's going to be about as high a transmissivity as you could get in the subsurface. And the consequence of that is that the well yields are very high, up to 20,000 gallons per minute. And so this really opens the door for very water intensive industries, agriculture, or other industries, catfish farms, for example, where they pump water out of the subsurface and use it for the feeding the fish ponds. Some of those are used in these clastic or these carbonate aquifers.